Hey, what's up, guys? Let's see what's going on here. Something is being on. All right. I'm gonna see if for some reason my thing is not there. Oh, maybe this needs to go here. There we go. Okay. That can probably be smaller too. All right, so I didn't really plan much for how we're going to go through this, but I think I'm going to start from the basics for game development. I'm going to assume that everybody has some programming knowledge for this. If the audio levels are kind of messed up, just leave a comment. I'm monitoring comments in either the YouTube chat or the Discord chatter channel. So any comments in either of those I should be able to see, no problem. But if you want to see your comment show up on screen, then you'll probably want to do it in the YouTube chat. Right, so we're going to get started with we're going to start with the very basics of how the technical, how a game runs in the background at a very basic level. And then we're going to go into a game engine and we're going to see kind of how that works in a little bit bigger scale. So to start off, we're just gonna make a little project in C++ just to show you the basics of what's going on. And if I'm moving too fast, you have any questions, I guess possible. Oh, you guys aren't allowed to see that. Come on. Oh God, what is? All right, I've got my work code auto loaded on me, and you guys aren't allowed to see that, so I'm just gotta get to a small game. All right, so we'll open in this window. Okay. And I'll try to make the font a little bit bigger. Okay, is that possible? How can I do that? Probably in here, font size, font. Oh, here we go. Use content. 22. That was everything except for what I wanted. Okay. Oh God, please let me put it back. Okay, good. Font. There we go. Depth range, mono size. 16. Maybe a little bit bigger than that. Yeah, that's probably good enough. All right, that's probably big enough, right? Okay, so the very basics of what a game is. Basically, a game at its core is literally just a while true loop, right? So every frame is one iteration of this while loop. So usually you're going to have something like a Boolean running equal true, and then while running here. And you're just going to set running to false whenever you want to end the game, right? If we want to make it simple, we can just say while running, we can do a std count, guess the number, and then put it sin, and then I should probably give it, what is it? I hope I don't do console applications very much, but let's just say int I. That's probably enough. Probably do that, right? And if I not equal, let's just say give it a hard-coded value, running equal false, and remove that extra one. So this is your very basic loop, right? Let's assume that this is a random number that's generated, and you're playing this. You're just trying to guess the number. This would be it, and here you would say, and then at the end you would put something like std count, you won the game. And there's going to be an issue here, maybe, but let's just see. So let's run that and see what that gives us. So this is a very basic thing. So you guess numbers, and that was wrong because obviously I put not equals 36. It'll help if you do it properly. So you guess a number, you say 2, it's wrong. You should probably print it's wrong or something, and then you do 36 and it prints you won the game. And that's your very basic game loop. And you're going to see pretty much every game, this is the very, very basics of it. Now, if we go a little bit deeper, you can break this up into a few different things. So you notice here there is input. So usually you're going to have an update loop, and then it's going to have a render frame here. And sometimes you're going to have like an update physics somewhere. I don't remember if it's usually before or after the update function. So let's just make those functions real quick. Update, void, update physics, and then void render. And then, so for in your update part, usually that's where you're going to have all of this logic here, right? And usually, so it's going to be a little bit weird because we're doing it kind of haphazardly, but I'm just going to put the running in here, kind of dirty, but what's this? Yeah, whatever. So this is what you're going to see, and every game engine you're going to see it looks very similar to this. You're going to have, there's usually some sort of update physics step, an update step, and then the render step. You don't even have to. You're never going to see explicitly inside of a game engine, but it's there behind the scenes. Now, one thing you're going to see in a game engine as well is that inside these update things, there's going to be a thing here. It's usually going to be like a float, and it's going to be called like delta time, or it's going to be like float time step. And what this is the time since the last frame was rendered, or yeah, the time in between frames. So way back in the day when games were first made, games would run as fast as they could, right? There would just be this while true loop, and it would be here, let's just put these here just to shut it up. So they're just going to go on forever and ever as fast as they can, and it didn't matter. But if you played any of the really old games on new hardware, you'll see that they run at like 3,000 times speed, and they're unplayable these days. And that's because they're programmed to run at as fast as the CPU can do it. But our CPUs are way faster now. So now what is done is it calculates a delta time or a time step that will tell you the time between frames, so you can scale all of your movement and stuff to that time step. So it will look something like, let's see if I can remember my high resolution clock. So it's chrono. Let's bring in chrono first. Chrono. Let's see if I can remember how to do this. Let's do chrono. Why is this not auto-completing? High resolution clock. And let's just say clock. Now, how is this done? So it's going to be, you're going to first you're going to get the start time here. Well, let's just block it out because I'm not going to show you how to actually program an engine here. But so basically, you're going to get your time. So you're going to get your original time. Let's say usually it's going to be something like 0.f, but it's going to be a high resolution clock get time, whatever. And then inside your loop here, you're going to get the current time, and let's just say this is going to be like 0.16f or something like that. If you do 60 divided by 30, I think that might be this number, or 60 divided by 60. Basically, for 60 frames per second or 30 frames per second, the common value is it's one of these ones. And then you're going to do your delta time equal current time minus original time, and then you're going to do original time equal current time, right? And then you're going to pass this delta time into these update functions. So then if you have any movement code in here, let's say you're moving a character, Usually you're going to move a character inside your update function or something. You're going to do like movement is .x equal speed times delta time. Right? Let's just make a struct vector 2 x int x int y vector 2 movement. There. That should be it, and then we'll make our speed float speed equal 5.f. All right. So what this is going to do is it's going to do the movement speed. It's going to be your speed times delta time. Speed is usually depending on your time step. So delta time is usually measured in seconds, but some places, that's why sometimes it's called time step, because sometimes it'll be measured differently, either milliseconds or whatever. Hey Phantom, you didn't miss too much. I'm just going over the basic structure of the, like at the very core of a game engine, just your main loop. You've got a couple of update functions and some delta time stuff. So your delta time is to scale your different values that you're going to be doing every frame, so that even if you're running at 600 frames per second or 10 frames per second, if you always multiply it by delta time, you're always going to get the same final value, or the same relative value, so that your game always runs at the same speed. So if for some reason you drop a bunch of frames, your game's running like crap, you're multiplying it by delta time, and everything's going to still look smooth on the user's end. This is actually going to be important. It's a very common problem people run into when they start working game engines. They're going to be like, why is my thing going ridiculously fast? I can't control it. Usually it's because you're not multiplying delta time by stuff. I'm trying to think of what else we can do at this basic level for game development. When I'm done explaining this, I'll go into the toy engine that I've been building for the Discord, to kind of show how all this gets put together a little bit, and then we'll go into the Godot game engine. So is there anything that's been unclear so far, or you'd like more clarity on, or anything? While I take a sip of this. I'm gonna give it another 2 seconds, and if not, then I will move on. I'm trying to think if there's anything here, because it's hard to really do too much rendering stuff in here. But you'll see here, if you look at here, even though I've got all this nonsense in the middle, this main loop here, which this should actually be inside update here, and let's just put this in physics to make it a little bit more thing. This will still work the same way it did before. It'll still ask for numbers, and then or delta time undeclared identifier. Oh yeah, I called it time step in this function. Yeah, and then see, this still works the same, guess numbers, and then when you hit 36, you win the game. So, let's see. So now that we've seen, this is the core, and now let's go a little bit up to the engine that I've been working on. I think it's this one will show it, this window. So you're going to see a little bit more, and I'm doing a lot of similar things that you see in the main engine. So when you're looking inside like a real engine, you see, usually you're going to find an entry point. So my engine is external, and you've got this main function here. This main function is the actual game. So you and you have a main function in here. Sorry, that will initialize everything. If you look deep inside here, this is so this class that I overrode overrides the HE game class. And if you look inside here, you're going to see many of the similar things that I was just talking about. See, you've got game loop, you've got render, and then inside this game loop function, you're going to see some other things. So you got physics update, initialize. So if we go into the definition of this, when you call to run the actual game, you're going to see it basically just starts a game loop. This is the while running loop. So this is mscript and stuff needs to be separate, but you'll see here literally while running, run the game loop. Inside the game loop itself, this is where I get my delta time. So you see here, I just get the time since last frame, multiply, subtract it from the current time, and then pass that into our physics update and our update functions. Then we call our render. We do some other stuff to make sure that it sticks to a certain FPS. That's also what delta time can be used for, or the same mechanism is forcing it to run at 60 frames per second, 100 frames per second. That's generally how it's done. You've got your elapsed time, and then this is just for doing that as well. You've got a bunch of services inside a game engine. Nothing you need to worry about too much, but usually you're gonna have something for input, you're gonna have something for rendering, you're gonna have something for these things usually are abstracted away that you don't have to worry about the windows and stuff like that in your own thing when you're working with an engine. But when we go to actually create the game, you're going to do stuff like this. So this is basically how we're getting into actually making a game with an engine now. You're going to, for the most part, you're going to set up what your inputs are. You're going to generally define your inputs ahead of time. Inside Unreal Engine, Unity, and Godot, you're going to have a GUI. You're going to basically be setting the same things. You're going to be setting a name for them. You're going to be giving it a key, and you're going to be giving it a scale. So, for example, here you see strafe is set to A and D, but D has a positive scale and A has a negative scale, which makes it so one action can do both things, and it can handle both. And when you go to your controller input, your scale is 1, but since it's an analog input, I'll show you here. When you're going right, you're getting +1. When you're going left, you're getting -1, and in the middle is 0. So you don't need to scale that at all. And that's how you can do things together like that. So you'll set up your inputs, and then this is more input stuff. And then you're going to override an update loop. So remember how I told you how there's always going to be an update and a physics update. Usually what you're going to be doing in your own code is you're either going to be hooking into it or overriding that function on your individual objects or on your project itself. So in this case, I've overridden an update function, and I get the input, and then I move the camera, or I think that's all I'm doing right now is I'm moving the camera, or you'll see here I'm also moving the light around. Here, I think, here, let's just show you what this looks like right now. I don't remember what it looks like, honestly. Haven't done this in a week or so since I finished cube maps. I tend to speak quickly as well, so just tell me to slow down if you want. Okay, well that's building. You're going to see usually your initialize functions are not, when you initialize your scenes, you're never going to do it directly inside a constructor, because usually other things need to be in place before you actually start setting up game objects. So you're usually going to have like an init function of some kind that's separate from your constructor. I think in this case I did it right in the constructor because I'm evil, but okay, what's this doing? Yeah, so this is just this. I guess cube maps is on a different machine. But yeah, so this is basically what this is doing, and you're going to just see that it's got a couple of objects that I've created, and on update, I'm just moving stuff around. When setting up the scene, this is going to be much simpler when you get to your when you're doing inside an engine. Usually you're going to just pull in a 3D model or an image. But in this case, we just set up the objects with each individual component. So you got your meshes, your textures. Yeah, this is Sea Lion. Sea Lion's the best, in my opinion. But and then you're going to create your stuff. This is just setting up the scene and some minor stuff. So that's the basics of how you're going to set things up. Like if you were going to do everything in code, not using a GUI, you're going to see stuff like this inside, even using like I did this kind of stuff in Unreal Engine too. You can set up all your stuff in code, and I sometimes I prefer to do it that way. So now I'm going to give it another few seconds because I don't know what the delay is like on this. So when you hear this, type 1 in chat or something. Just let me know so I can measure the delay. And then when that happens, or you can actually just tell me what time it is on the screen you're watching, and I can probably guess the delay. So I know how long to wait for answers. Yeah, so this is basic making a game using a game engine if it was all code. Now we're going to go into, and we're actually going to grab the Godot game engine, and we're going to actually just, I'll show you some of the main common components. Actually, before I do that, I'll show you some other stuff. So you'll notice inside here I'm creating components. Where is it? Setup scene. So you can see here I'm creating components and adding them to here. It's like I'm adding components directly, add component, like component. So generally game engines will okay. So it's about a minute delay. Okay. Cool. All right, so you're gonna notice that we're adding components to stuff. So there's a bunch of like common components that you'll often see in most game engines that if you're going between Godot or Unreal or Unity, you can just Google for the same component name, and you're going to get basically the same things. They just work a little bit differently. So you're going to notice here inside here, I think it's like core components. I've only got a few. I've got a transform component, which is very common. You're going to want to find the transform on your game objects. That tells it where the objects are in space. The mesh components are very common. And I don't know if light is going to be a common component, but often you'll have like a directional light, ambient light, point light, that kind of stuff. And I think camera is usually its own component as well. Yeah, okay. That's what I figured. It's about a minute behind. I tried to figure out how to minimize that delay, but you know, it's annoying, but we gotta live with it. So let's go get Godot. And do I have that on here right now? Doesn't look like I do. So we're gonna go get it. It's gonna not take long because it's tiny, because Godot is the best engine. Go.engine.org, I think. Yeah. So you can just hit the download button. I'm sure you can figure out how to download the engine. If you're looking to just get started and you don't have a very, like, if you're on a laptop, I suggest the Godot engine. It's 36 megabytes and doesn't require large install processes or anything. It just kind of works. And then let's go into our Discord and grab some resources from Kenny that we linked to. Where's Kenny? There we go. Let's find something. Does he have a platformer? Animated characters. What does this look like? Let's download this. Emotes, animal pack. Platformer characters. This will probably work. Yeah, okay. We'll do this. Okay, so we've got Godot. We'll put this here. And this is why I like Godot. It is installed now. And we can just double click that to open it. And let's ignore the legally acquired stuff in that folder. Don't pay attention to it. Platformer stuff. And we'll open this. All right. Do we want the vectors? I don't think we want the vectors. No, I'll keep them there. Okay. So Godot. So we are going to just create a new project here. We're going to put it inside platformer stuff. And we are going to call this intro to game dev. Please choose an empty folder, create folder. All right. We'll just use ES3 because it's better, and that's fine. Create that. Now we will go back inside here, grab this PNG, no, we'll grab this, copy this, new folder. So usually you're gonna have like a folder that you'll call like assets or something like that, and then you'll make a folder of something like textures, and you'll put all of your stuff in there. It'll import all of that now. Okay, so this is Godot, and most engines will open up something like this. Every engine is going to be a little bit different on how things work, but I'll show you the basic flow in Godot. And if you look up any beginner game development tutorials for any of the engines, you'll be able to get a lot of the same information on how to start with their specific stuff. So we're going to make, let's just say we're going to make a basic platformer for now. All right, so let's look at these assets and see what we have. These are just characters, limbs, poses. Oh no. Okay, so these are different poses. That's okay. I'll take this. These look okay. Idle, hurt. Where's the walk? Walk 1, walk 2. 2-frame walk animation. Oh, sprite sheet, even better. Okay, so a lot of times when you're working 2D, you'll be working with like sprite sheets like this too. I don't know this. Is it really just a 2-frame walk animation? Either way, it doesn't matter. We'll figure it out. So first thing we're gonna want to do is we're also going to need some sort of platforms too. There's got to be something simple. Fish pack, sports pack, generic items, rune pack. Come on, Kenny. Come on, Kenny. Abstract platformer. There we go. This will work. Grab that. Is it done yet? It's done. Okay. Abstract platformer. And then we can go into here. Oh no, this one. Extract here. Sprite sheet. Yeah, that's what we want. So your sprite sheet's gonna look something like this, and we can figure out how we're gonna use it later. Apparently there's a whole bunch of stuff inside here. Tile sheet, is that what I want? Oh no, this is what I want. I want the tile sheet. That'll be better. 2 times. Let's just do that one. Platformer stuff, intro to game dev, assets, textures, and then we'll just say level textures, and we'll put that inside there. Okay. So let's start with some basics. So we're going to create a 2D game. 3D is very similar to 2D, except you're working with a third dimension. So a lot of the math is going to be the same, and a lot of the actual processes are going to be the same, except you're going to be working in a 3D space like this versus a 2D space like this. And Godot actually has a much nicer interface for two-dimensional stuff than Unity and Unreal does. If you're working with 2D, I suggest to not even look at Unreal Engine. 2D and Unreal Engine is a pain. If you're working at 3D, 3D is easiest in Unreal Engine, in my opinion. Second would be Unity. The third would be Godot, but I haven't done any 3D in Godot yet. It's just not as powerful yet. We're waiting on Godot 4.0 right now. So this is going to go longer than 3 o'clock, obviously. We're just getting into an engine now. So first thing we're going to do is in Godot we need to create a 2D scene. So we'll just call this main level, right? So let's go here. Let's close all of this. And we're going to create a new, inside here, we're going to create a new folder called levels. We'll call them scenes because they're not really levels, they're going to be scenes. So this is going to be let's call this main menu. And then we're going to save this inside assets as main menu. Oops, put that in scenes. And then we're going to create another new scene. And we're going to call this, let's just call it level 1. Level 1, right? And we'll save this inside scenes as level 1. So we're going to skip the main menu right now. We're just going to work on level 1, and then we'll try to put a menu together quickly. We're going to do this as quickly as possible because a lot of this you're going to learn just by doing. So the first thing is, let's say we want to our goal is going to be to have a character in the world with some floor on the ground, and you can fall on it and walk along it, right? Seems simple enough. So let's look at our textures. Let's look at player. Yeah, let's do player tile sheet. So if we bring this in here, you can just drag and drop images into Godot, and you'll see it shows up in your tree on the left, right? So this is a sprite. You'll see that the class type is here. It's called Sprite, and you have various things you can do here. So I believe that you can do region enabled. So you can enable a region. So when you're using a tile sheet, you're going to want to just have one texture like this, right? So you're going to have, let's say here, how big is this texture for one? You should be able to see it inside. Here it's 720 by 330. So if we take, so that means what? It's 110 high? Yeah, it's 110 high. And how? 1, 2, 3, 4, 5, 6, 7, 8, 9. What's 720? That's 8? 8 times 9, right? Is 72? Yeah, so it's 9. So it's 3 by 9. So that's what, 90? 720 divided by 9 is 90? 80. Yeah, of course it is. So here in your region, you're going to say X is going to be 80, I believe, and Y is going to be 110, if I was right. Maybe I'm not. Oh, no. This is XY. This is going to be 80, 110. And we got the one frame of our person. You'll see here, if you look at the bottom, we've got one thing. Now we want our frames to be our walking animation, which looks to me, let's find our player walk animations, what they look like. I think it's these two here. Yeah, it's that one and this one, right? So if we look back here, we want to be one down, so we want to go 110 down. So now we're on our first frame of walking animation. And where's the idle animation actually? Idle, yeah, our idle animation is this one. So where is the idle animation? Idle animation is this first one. This tile sheet is not laid out correctly. I don't like it. But anyways, this is annoying. Usually you would want your idle to be next to your walking animations, but it's okay. We'll figure it out. We've got horizontal frames, vertical frames, frame 1, frame. So we've got one horizontal frame. No. Interesting. Okay. So here, if we make our width 160, we get 2 frames, horizontal frames 2, and now we can flip between frame 1 and frame 2. Something like that. Either way, we're just going to sit on frame 1 for now. Yeah. And let's add some physics to them. So that we can start doing some interesting stuff. So remember how I mentioned that there are common components that you're going to find in pretty much every engine. Usually what you're going to do is you're going to have something like this. So here we're going to call this guy player. And we're going to add a physics component to him. Now there's a couple of common components. If we go into here, add child node, that's how it works in Godot. Here you might see, in other engines, you might see add component or something like that. Yeah, this is super fun. Once you kind of know your way around and you have an idea, you can just mess around with it. And you get a lot of programming practice. We'll get into it, the programming side of things in a minute. So if we add child node here, you're going to see all the different stuff you can add to it. We're interested in 2 specific types of components. There's the Kinematic Body, 2D, which is a physics-enabled body, or I should say, collision-enabled body that you can move around at will, but is not affected by normal physics system. There's also, if you want to integrate into like a normal physics system, a rigid body. And those two things are very common across all game engines, rigid bodies and kinematic bodies. That they're very common things. So even if you go into Unity, look, just for demonstration purposes, if I go here, if I go Unity, rigid body shows up, and if I go Unreal Engine, rigid body, it shows up, right? So these basic component types, they're the same in pretty much every engine. Yeah, I've forgotten that I'm supposed to be doing stuff a lot while doing this kind of stuff too. So we're going to add, so choosing what you want to do is take some experience, but generally if you're using something that is like a 2D platformer, a kinematic body makes more sense than a rigid body. If you're doing something like Angry Birds, where you're going to be adding force to something, like your Angry Bird, you're doing like a little like slingshot thing, you're adding force to it, and then you're letting the physics system do its thing, you're going to be using a rigid body for that. So we're going to add a kinematic body to this, and you're going to see here, Godot is friendly enough to have a little warning here that says you have something that has collision, that expects collision, but you didn't give it a collision shape. Right, so let's add that now. So you'll go in here and you'll also add under your player we'll call it a collision shape. And actually, we'll likely put that underneath kinematic body. And then here you'll pick our shape. So for our guy, we're going to use a rectangle shape. We'll just zoom in a little bit. And we're just going to line it up with his feet. And now, in general, you'll notice old games are worse for this than newer games. But newer games, you'll actually find that you're not covering the entire body with your collision shape, mostly because you don't want the game to feel unfair to the player, right? So we've all played that old Mario game on like our old Mario game on Super Nintendo or NES, where you get like a mile away from a spike and there's a clear gap between you and the thing, but you still die. Is because it's using a square, but the square is set to like this, right? And that feels super unfair when you're working on it. So when you're working on, usually you want to make it as close to the player as possible without, usually you want to give it a little bit of room, and like I usually don't include stuff like hair. Yeah, we're gonna do some GD script inside here. We probably won't do C++ and Godot in this one, because that gets really complicated, because it's kind of hard to script with C++. In Godot to make plugins with, I like using the C++, but the scripting requires the external scripting language and stuff, and I don't really like the way Godot does its external languages. Other than the native C# integration is done fairly well, and the GD script obviously is done fairly well. So this is our guy. That's where he's going to be. Now we need gravity, right? So let's save our person here. So usually, so we got assets, scenes, texture. So scenes, in Godot, everything is a scene. So every single node, technically everything is a node, and a node is also a scene once it's saved. So yeah, well, we're going to separate them in here. We're going to make a new folder, and we're going to say game objects here. And inside here, we are going to save our player. So you can right click player and go save branch as scene. And inside assets, game object, we'll just put player.tscm, right? And actually, we're going to make a new folder and put player inside here, because player is actually going to have a script attached to it. So let's add some scripts. And I like the interface in Godot too. I like it much better than I like Unity. I like Unreal Engine, but like I said, you don't do 2D engine. Freeform options for collision. So do you mean, if you mean, I think I know what you mean. Let's go inside here. So just to show you, now that I've saved out the player into its own scene, now I need to open it inside its player scene here. Other engines have a similar facility. In Unity, it's called Prefabs. So you're going to save a prefab and you're going to edit your prefab. I don't remember how Unreal saves its prefabricated stuff. They might call them prefabs too. Let's look at it. Unreal Engine prefabs. Yeah, I think it's prefab. Yeah, so they both have a prefab system. Godot calls them scenes, but it's here. Yeah, so Freeform Collision, let's just hide this and we'll add a new thing. So I think you can do collision shape or collision shape here. And I think inside here you can do usually you want to do convex collisions. Concave, I believe, are kind of janky in most engines because they're more expensive or something. So you can make a concave. I did this before, I just have to remember how to do it. No, it's not this one. You'll do, let's see. I've done it before, I just have to figure out. Collision. It's probably collision polygon 2D here. So here you're gonna see, you got it here, and here are the tools that I'm looking for. Just create point. So you're gonna do like here, and you mean like doing like this for your collision shape? And then just defining it like this. This is what you mean, Neil? I think this is what you meant. Then you do this, and then you got your collision shape like this, and you can move it around. Now, there are issues with when you use shapes like this. One is that they're more expensive. So, checking collision against a series of vertices like this is a lot more expensive than just doing a square like this. And you're not going to be gaining as much. You're not going to be gaining as much gameplay advantage as you might think you would. Mostly because when you're doing this, when you're checking against a square. So if you're only using a square like this, the only math you need to do really is basic intersection, or even if you can just do a point, is the point inside the square, which is very cheap. If you're doing a collision polygon like this, I don't even know how to do the math like that, because that's why I'm in school. So, but it's a lot more expensive because you have to do it, like, I think that's why these are separated in different things. You have to do different planar intersections, and you're getting into like kind of complex linear algebra type stuff. So we're gonna stick with a square, and then you also get the advantage when you have the square is that you've got a flat bottom. So if you start using a physics, and if you're using the proper physics stuff and you're not using a square, you might see your character hit something and then start leaning over, or if your shape isn't defined right, you might see it just like kind of wobble and stuff like that. You can run into issues that are going to be really annoying to fix if you hadn't just used the square. Usually, for platformers, you're going to be using variations of squares for your main characters, and then other things will be a little bit different. So we've got our player. Let's add a script to it. So in Godot, to add a script, you just click this little plus script button on it, and it's going to create it in the same folder with the same name as the object. And if you see here, this is basically Python. So GDScript inside the Godot engine is basically, not entirely, it's a derivation of Python basically. So what just yelled at me? Couldn't save scene, likely dependencies, if it couldn't be, whatever. What? Cancel? Not letting me save this scene? Why can't I save this scene? Whatever, let's just open open it again. See why it... Okay, let's just add the player back to the scene. Okay. There we go. So our player's back in the scene. We can save it. Good. So our player is here, and we'll leave this for now. We're actually going to add a script to the level itself, and we're going to make a new folder for that because it's going to have a script, level 1. Move this inside here. And what we're going to do is we're going to add a script inside level 1 that's going to add gravity to the players, or to all the game objects inside the scene, right? So let's see, level 1 is here. So we're going to add script button here. Now, it's been a while since I've done too much in Godot, so let's see if I remember all the things. So first thing we're going to need is we're going to need to get a reference to the player. So on here, we do onReadyBar player object equal player, and I think that's enough. Am I in the level 1 script? No, I'm in the wrong script. Obviously, we'll do that. So, and that means that's probably why it wasn't auto-completing. Yeah, okay. So in Godot, I'm gonna give a slight Godot tutorial throughout this as well, but in Godot, onReady means that after this, so remember I told you how in general you don't usually do initialization stuff inside a constructor. OnReady is a keyword you put in front of stuff that says I want to initialize this variable after everything else of mine has been initialized. So, and then this $sign symbol here means get child, basically. So, or get node, I think is actually the, so this is identical to if I had done, I believe it's get node player. But this $sign is just a convenience function for this because it's something you'll do fairly often. And get node looks directly underneath your player, and you can also get, so if you notice here, player has a Kinematic Body 2D here. Let's just call this we'll just call this body for simplicity. If we go back here, we could actually just do /body like that, and even here we do /body like that as well, and that will get the child of it. But we want the entire player itself. Okay, so the next thing we wanted to do now, we want to add gravity. So let's just create a. No, I'm not going to be doing C# today because it'll complicate stuff. But we'll do. I could do C# in the future if we were interested in that. It's something I would need to. I haven't done C# in Godot myself yet, but it could be interesting. Any other? No, I think that's it. So let's add gravity. So let's just say we want to add a gravity float. Now I'm going to show you how to look stuff up as well. So what I'm trying to do, I'll explain what I'm trying to do and I'll tell you, then we'll go look for how to do it. When you click your level here, you'll see there's script here. You can also add the script variables inside here for you to set from the editor as well. Console.writeLine. So what we're going to do here is I want to add a gravity function so that I can change the gravity from the editor, right? So I'll just type editor variable Godot. It's a keyword. I just forget what it's called. I think like extern or export. That's what I want. Export. So we would just export. I think we do it like this. And then if I need var, yeah, export float var gravity. I think that's it. GD script. I personally think it's really easy because it's basically just Python. But if you're see Neil, you should be, if you know any programming languages, you should be able to learn it in a day. If you don't know any programming languages, it'll take you as long as any other language. Honestly, it's fairly simple. So you'll see here that as soon as I added this export float bar gravity, we now have a gravity variable here, and we're going to say that gravity is going to be minus 9.8. Probably a little bit high, but we're going to use real world value for now. So that's minus 9.8 meters per second squared, basic gravity. So if you remember from earlier as well, in every game engine, you're going to have update functions that you can override, right? So if you do here, you're going to see going to be a process. So in Godot they call it process, but this is your update function here. And you'll see it also takes the delta, which is the delta time we talked about. So now what we want to do is we want to bring the player down every frame by gravity. Yeah, we want to bring the player down every frame using our gravity variable. So here we're going to do player object dot translate, and then it's a vector 2 offset, so we're going to do vector 2, and then it's going to be, we're not going to offset it by 0, but we're going to do minus, we're going to say it's going to be gravity times delta time, and that will give us a consistent speed no matter on the frame rate that the player has. So now if we go here, yeah, I've done C# before. I know C# as a language. I just haven't used it in Godot. So we want to select the current one, and if we play this, you're going to see it might happen really quickly. Oh, delta time is not. Oh, it's just called delta. Yeah. Stop that. Save that. Press play, and now it should work better this time. And we are going the wrong direction. So gravity needs to be a positive variable. Now that's good. Now it's going really slow. You can see it's slowly going down every frame. So what we know from that is that our gravity needs to be much bigger. So let's just make it 98, which might be way too much, but let's just see. Let's factor of 10 it. Interesting. It's really slow. So let's do. That's way too fast. I was at 98, so let's do 500. There we go. That's probably fast enough. Okay. Yeah, you can make anything you want on Godot. If you look at some of my previous videos, you'll see that I lost the source code because I'm an idiot. But my previous streams and a couple of them, I was making like a super casual stupid clicker rage game in Godot. I like Godot. I mean, you can make anything you want in Godot. Godot. I prefer Godot, but some people say Godot, so I switch between them. So we got this. Now let's just make him stop. So since he's using a kinematic body, it's very easy to make him stop on stuff. So I believe anyway. We don't want this. We want get node body dot move. Okay, all right. So this is what we want. We want move and slide. So here's doing. So this is just. I'm just correcting myself here. So translation is just going to move it in a flat way. Move and slide. What it's going to do is it's how you should interact with your kinematic bodies in general, right? So if we do this, you're going to see it takes a linear velocity in an up direction, right? So our linear velocity is just right now is just going to be gravity times delta, right? we're gonna have to play with this more. But we'll do this for now. And then our up vector is going to be 0, 1. All right. 300. Write and copy tutorial. What you should do is find, so this tutorial or this session live stream is mostly for people who have a general idea of programming in general. The people I'm hosting this for is for the SNHU Game Jam. They already have a strong background, or at least some background in programming itself, but they haven't necessarily done game programming. So I'm kind of going at it from that perspective. If you're interested in learning how to start game development from scratch, not even knowing how to program, I suggest there's a creator, if you're doing Godot anyway, there's a creator called GDQuest, GDQuest, GDQuest. He makes a lot of very beginner-friendly tutorials, and I would suggest checking him out if you're interested in Godot specifically. So this should do roughly the same thing, but it might be okay. Cannot convert argument 1 from float to vector to 0, like this. And that didn't work for some reason. I think that needs to happen here. Let's do this. So we're going to do this in a slightly different way. In our player script, we are going to override the process function. I'm going to put that inside here. We're going to have a function inside here called setGravity. Gravity. And we're going to say gravity equal gravity. Then we're going to say gravity equals, let's just give it 100 by default. And this will go like this. Player object. Oh, all I need to do is get node here. We're going to get the body like this. All right, and then inside our level 1 on a ready function, we're going to say player object set gravity. C#. Honestly, if you're going to just be starting off and you don't know any programming, I would suggest, if you're doing game development to start, I would suggest GDScript. It's easier in general. You don't have to worry about some of the more annoying things about programming. Why isn't this working? This should be working. I'm annoyed. Process, move inside. Should this be in physics process? Maybe it needs to be in physics process. Okay, let's just... Okay, what? Oh. I think I know what I'm doing wrong. So we're going to reorganize this shape. So the kinematic body is going to be the top level. So we're going to do change type kinematic body, and then this one here is going to be here, and then here is going to be change type Sprite, and then this is going to be called Sprite. We are going to give it Detector. So what I did wrong there was that transform region enabled 0, 110, 260, 160, 110, and then animation, 2 horizontal frames. Okay. Good, all right. And here we're just going to change the frame. All right, so I think that's going to do what I wanted it to do now. Extend, and I'll change this, Kinematic Body 2D, and then we can just call move and slide. So the reason this doesn't work is that your kinematic body, there we go, needs to be it needs to be the root component of your object. Otherwise, you're moving the. So what was happening is, if we go inside here, what was happening was basically I was taking this, and this was going this way, but since it was a child of the sprite wasn't moving, but the body was. So by making it the root component, now the body works, and now we can go back here, and we can change it back to gravity times delta. There we go. All right. And now, that should work. Do I need to change the gravity again for level 1? Now that it's using move and slide? No. It's not overriding gravity here. Can I do this? I doubt it's going to work. No. Why is this not level 1? Gravity. This should be setting the gravity on ready. There it goes. Okay, so it just needs to be really big. Okay. How big does it need to be? I don't know why it needs to be this big, but we'll deal with that later. But okay, so we've got basic gravity working now. Now, what I was going to show you before that nonsense, before it stopped working, was now we want it to, I'm going to show you, since we use a kinematic body here, we can use a basic, another collision shape down here. And we don't even need to do anything fancy. We can literally just put a collision shape, an invisible one. Where is it? We will make it a rectangle. We will move it down here. It can take you, like, I've been programming games for years and years, and even I'm not amazing at it. So I mean, it can take as long or as little as you want to make a. I mean, expect it to be work. It's not. I'm not going to tell you it's not work. What? Did it? It didn't stop. Why didn't it stop? Should have stopped. Oh, it needs to be another. Needs to be a add child. Static body. So all right, so we're going to create a static body, and to that add the collision shape to it, right? And now it should stop on the body. So that is the power of game engines, right? So since I gave this guy a kinematic body, and I gave this one piece here, I gave it a static body. When you go in, you'll notice that it stops. Let me drink a little bit. And that's the very basics. Now I don't, for gravity, usually you're going to be, it's not going to be, so let's see. So here, what we're going to do is we got a gravity here. Now we got on ready bar. This is not going to be on ready bar. This is going to be one. We're going to take this off on ready. Actually, no, we'll leave it on ready. We'll also do bar, and we'll call it velocity. And this one here is going to be a vector 2, and it's going to be vector 2, 0, 0. So this is the velocity, and our physics process itself is no longer going to be, it's no longer going to be calling this here directly. It's going to be putting our velocity inside here. And then our velocity dot y is going to, we're going to add, I don't think plus equal is a thing in Godot, but let's see, velocity dot y plus gravity, right? Because gravity is something that gets added every frame, and that's so you know it's 9.8 meters per second squared. So now it's going to go way too fast. I'm almost guaranteed. Yeah, so that's way too fast now that we've fixed gravity a little bit. So let's go back inside here and scale this back quite a bit. See what 1,000 looks like. So it's still way too fast. And then we will do 500. Still way too fast. So now you see that now that we've got gravity working kind of properly. Oof, this is still... Oh, wait, I'm not doing times delta time, am I? And like I told you before, don't forget to multiply delta. And actually, the way this algorithm works in Godot is once you call move and slide, you will assign that to the velocity so that when it stops, it'll work. Boom. All right, so now we've got proper gravity, and it's still a little bit high. So let's continue to make that smaller. Oof, this is rough. Still going nuts. It just it just starts off doing nothing and then just goes. So I don't remember what I did. Here, let's just steal that from someone. Godot platformer gravity function. I don't know. I'm sure it's here. Motion y plus equal gravity. That's fine. Motion y lerp. Plus equal gravity. Yeah. So I'm not wrong. I mean, velocity is that 0 minus 1. I see. So this is going to go the other direction, right? No. Yeah, so that's fine. Why is this so... I'm gonna keep this simple. I gotta figure out why this is. Turn off set gravity inside here. It shouldn't be... It shouldn't be being so crazy. Why is that going so nuts? Oh, that's why. Okay, that was it there. All right. That's what happens when you're trying to do things quickly. See, you notice he's accelerating. That's right. That's correct. But let's make him accelerate faster. Yeah, you're right. That's what it was. Almost there. Okay. All right. Good enough. almost good enough. Usually this is going to be fairly strong. Okay, good enough. I'm going to call that good enough. So we've got our player falling and it's hitting the ground, right? Let's say we want to make a move now, right? We want to make him run around. So what we're going to need to do is do that. And what did I set it up as in my script? 1800. Let's call it 2500. Okay. Okay, so we've got our script here and it's working fine. Now we want to make a move. So remember how I mentioned we have to set up like our input management stuff? So if you go inside project, I think it's project settings, input map, you're going to see all of the commands here, right? So as I mentioned before, these are all default ones that usually you don't want to play with in Godot because it's all your basic UI stuff. So when we build a UI, all of the tab and enter and stuff like that, that's all wired up using these default ones. But let's just say we want to add a jump command, right? So let's add jump. And our jump, we are going to make it the space key. And yeah, we'll just use this. So that's our space key. Now let's do, so we want to make him jump. So I forget the actual command, input Godot. It's just going to be a simple action press, get action strength, input examples. This will probably help. If function input event, this is what I want. All right, we'll do this because I'm going to do it using this little blurb because it's going to be process delta. Oh, it says it wants in physics process, so let's do it inside here. Okay. So first we will do gravity, and then after gravity we will check to see if he's jumping, right? So to do the jump, it's fairly simple. What we're going to do is we take the velocity dot y, and we actually just need to say equal, and then we put the jump strength. So we could make it here. We can do export float var jump strength equal, and let's just say 1,000. It's probably minus 1,000. And here we will just say jump strength. Now, if we go inside here, hit here, and we can jump. And that's how easy it is to add jump. Now, you'll notice here that I'm pressing it and letting it go, right? If I hold the space bar, I keep on going forever. That's a common problem you're going to see. That is because we're using this is action pressed jump, right? So usually what's going to happen is you're going to have something like a function up here, and we call it can jump. Let's say can jump. And this is going to be Boolean equal true. And then here we will set can jump equal false. And then what we want to do is we want to check to see once the player is on the ground. Oops. Like let's say we move him, and once the player is on the ground, he can jump. Or it resets his can jump flag. So I believe that there is we're going to put it inside process because this is, I believe there's a is on ground, is on floor. So if is on floor, can jump equal true. And now what this should do is if I hold it, it still works. Why did that still work? Oh, right. And can jump. So So now, if I'm just holding the space bar now. So every time he hits the ground, I can jump again, but it doesn't let me jump more than once. If you want to do a double jump, you can do bar. We'll make this an export integer bar number of jumps equal 2, and we will say can jump, and what this will be is can jump equal, so it'll be var jumps left integer equal number of jumps, and then we will do can jump equal number jumps left, so jumps left minus equal 1, and jumps left equal 0, not equal 0, right? If it's not equal 0, you can jump. Yeah, that makes sense. And yeah, that should do it. And when we hit the floor, we want to put jump left equal number of jumps. Now this should give him a double jump. No, what did I screw up? Who can see what I screwed up before I see what I screwed up? Velocity y, jump strength. Okay, so it's only this stuff. Jump left minus equal 1. If it's not equal to 0, oh. No. Let's just say bigger than 0 for 1. What did I do wrong here? Oh. So what's happening here, you'll see that it prints it. The logic is sound. What's happening here is that I'm pressing this, it's triggering twice really quickly, and then it's going. So what we could do it the other way. We'll do it the other way just for this case. There's ways to fix it. But if you use this input event, and we do this, and we do here, and we move that from here, that should fix it. Yeah. But now I have infinite jumps. Oh, and can jump. Now I have 2 jumps. So that's how you would do a double jump. So the difference between the way we did it before. So let's copy this just so I can have them both together. So the difference between what we did here and what we did here is this is fired. This is fired. I don't know what you mean by needs extra logic. It's working pretty well now. I mean, if you want your second jump to be lower than your first jump, you're gonna need more logic. But if you just want 2 identical jumps, this will be exactly what you need. But I'm just doing basic ideas of how you would do input. Double jump is my first thing. So the input event here is going to be is only fired when there's a change, when there's an event. This one, we're checking for the value of that key every single frame. So when you press space, when I was pressing space here, I was holding space long enough for 2 frames to go by. So it would, message retracted, whatever. Once both those frames went by, it was turning can jump to false. So it didn't look like it was doing anything, but it was actually jumping twice right next to each other. And since we are using a since we are using a fixed value here, it just looked, we were just setting the same value twice, 2 frames in a row, so it looked identical. Here, it's waiting for you to waiting for me to specifically press the button, like press it, let go, press it, for it to be fired twice. And that's why this makes more sense in here. So you'll see here, we got our double jump. And if we wanted, see, and depending on where you want to do it, if I double jump right there, you get lower. If you double jump at the peak, you get a much higher. And that's a pretty good double jump there. So now we want to do, let's say we want to move left and right. It's going to be the same idea. It's going to be inside here. It's going to be using that same here. But what we're going to do is we're going to say get, first we're going to make the input settings here. We're going to say move right, let's say. So we're going to say move right. Physical key is going to be D. And no. Joy axis. Can I do this? No, I guess. Does Godot? I guess Godot doesn't have the axis system like other things do. So okay. So I mean, I guess we're gonna do a move right, and we're gonna do a move left. And this one's gonna be A. We're gonna close that. And then we're gonna do the same thing here. So we're gonna look for move right. And if move right, and we're gonna say, we're gonna add another thing here. We're gonna say export float bar movement speed. Now jump speed was that, so let's just say movement speed of probably around like 500 might be okay. So we're gonna take our movement speed, and since it's exported, we can movement speed like this, and move right. So we'll say velocity.x plus equal movement speed, and then we will take move left, and we will say minus equal movement speed, and now that should be, oof, too fast. Let's do 100 then. All right, so now we've got, so you'll notice here, okay, it fell off the edge. Let's go into our level and make it so that it doesn't do that anymore. Let's just say scene, duplicate this, collision shape, make unique. All right, and then we will again duplicate this as well and move this on this side. All right, so we've got super slidey physics now. So this is move and slide. We can move and collide. First, let's just see here. I've got here it's -1. Pretty sure if I change that to 1, it's going to, yeah, no, still sliding a lot. Move and slide. Slide's too much. Godot, move and slide. Nice. Oh yeah, it's probably, you're probably right there. See what happens when you are completely right as well. You would have to use delta there. And like I said, it's one of the most common mistakes when you're doing anything. Now this is going to be moving super slow now. Still slides, but we can make them faster at least. All right, so that's, yeah, okay, so that's reasonable for now. Let's make it 800. But how do we move and slide with snap. Why does that motion, collision, collision? You need to use it all the time, yeah, okay. So why? Overriding your live friends, but there is no acceleration because I can't build up. Velocity, Godot, move and slide. Friction. That's what I want. I want to add friction to it. That's fine. Lerp friction. I see. We want to do a lerp. Slow down when there is no input. That makes sense. So we will do elif else we're just going to steal that. And what was the friction value? Between 0 and 1? Yeah, whatever. So friction. Let's do that. Velocity is not declared in the current scope. All right, so that should give us friction. Friction. All right, let's turn down the friction a little bit, but at least we have friction. 0.8 I think is usually a good value for that. That's better. That's basically what we did. We could have done it that way, where we just stop movement completely. But usually, if you look at Mario, and this is stopping movement completely as well. I don't know why this friction value should be. There it goes. Okay. So if you look at Mario, what it does is it actually slowly decelerates instead of coming to a full stop. Otherwise, it feels kind of weird. So now, see, now we've got. Oh, can jump did not fix itself because this. Nope. Let's take off with snap then. Huh. My jumping broke. Why did my jumping break? Oh, there it goes. That's better. All right. So now we've got it so that, see, notice how, and then we would also do here, this feels weird, elif is on floor. So now we don't want to completely stop when we're in midair. So we want to stop when we hit the ground, right? So no friction in the air. That's what this does. So this feels way better. Movement speed is 1,000. We need that to be faster. I don't know. We'll figure. It's good enough for now to get the point across. But that's basically how you would do movement. And if you want to, like now, if you want to, we've got this here. Sure. Why don't we add like an enemy of some kind? So let's find a zombie. Let's add a zombie. zombie tile sheet. Now we will want to actually add a new kinematic body. We will call it a zombie. And then this needs a collision shape. And then we will add a rectangle here. First we will fix this. This looks, I'm pretty sure it's the same size, so this will be 110, 160, 110, animation, 2 horizontal frames, and we'll use this one. Move him down here. Oops, we'll move him down here. Oh. Now, one thing you want to usually do is make sure that your transforms are zeroed out. Otherwise, you're going to get some weird behavior. You want everything to line up properly. And then we will add this collision shape here. All right, so one other thing that we'll do before we finish off the zombie, because we're going to need similar stuff, is, so we're going to look at some, first we're going to make it, so if you look here, when we're turning left and we're turning right, he's always facing the same direction. So what we need to do is inside here, we can probably do it in process. We can say if velocity dot no. We want him to be looking in the direction that you are pressing, not necessarily the one that you're moving in. So let's just do it here. So if we look at our player here, there's going to be on our sprite, we should look at our player here. On our sprite, there's going to be a flip type thing, flip H here. This is what we want to press. We want to toggle this flip switch. So if he's moving right, it's going to be sprite dot flip H equal false, and here equal true. And then if he's on the floor and there's no input, what we're going to do is we're going to say false if velocity bigger or equal to 0, else true. Now that should do it. Oh, dot x. That should do what I'm trying to do. So move left, move right, yeah. And now, yeah, there we go. Look at this. Cool. This is too much fun. Every time you start having things working properly, I always get a big stupid smile on my face. All right, so we got, see now it looks like it actually works, right? The thing I did where this last one here, maybe a little bit weird, probably don't need that one. So now, see now I can moonwalk. All right, so we've got that. Now, one thing that we're gonna start looking to, we're gonna make it kind of object-oriented a little bit now. What we're going to do is a lot of this this logic, the velocity code, the flip code, maybe. Screw it. We can make this. We can use reuse a lot of this code for our zombie, but that's going to take a while. We're reaching. We've been going for an hour and 40 minutes, so probably should wrap this up at some point. But for the most part, well, let's make our zombie. And what we're going to do is we're going to do two things. What we're going to finish off is we're going to make our zombie. He's just going to walk back and forth until he hits the sides, and then he's going to turn around and keep on walking. Then we're going to make it so our guy can jump on his head. Should be simple enough. And once he jumps on his head, it destroys the zombie. And if the zombie is destroyed, then you win. And then we could probably easily make it so that it keeps on spawning zombies, and then it can make waves and stuff like that. There's plenty of things you can do here, but that's what we're going to start off with. We're going to make, so we're in our level 1, we got our zombie. Our Mr. Zombie here needs to be saved as its own thing. Save branch as scene. We're going to make a new folder called zombie here. And our zombie itself, let's open him up. Open our zombie. He's got his tile sheet, all of that. Let's create our zombie script. Delete all the boilerplate. Go into our player, we're going to steal some stuff. We are going to steal all of it. All of this. Except for the jump stuff, because our zombie's not going to jump. He could jump. I actually had a thing that made things jump randomly too. So this is fine. Ready, input, that's fine. We don't need this. Physics process. We can copy this code into here, into our func physics process. Now again, you'll see that obviously we should abstract a lot of this stuff out. The movement code itself is here. I'm doing it with this, but that can probably be put into like a movement command, and that could be abstracted out to be used by both. But we're going to do this. Is on floor, that's fine. Gravity, we'll do this as well. Make sure that the gravity is the same for everything. Okay, so what we want to do is we need to pick a direction. So bool is moving right equal, you know what? We'll make it equal false right now, but that's going to be randomized later. Why is this? Oh, bar is moving right. Boolean. So is moving right Boolean false, and then physics process. So first we need to say if he's moving right, else this. And he's actually just never going to be doing this. And his movement speed is actually going to be slower. And then in our process function, we're going to say func process if is on wall is moving right is equal to not is moving right. And that should make him move left and right continuously. So this is not called Sprite, we call it Sprite. Restart that. There we go. Now we have a zombie that chases us around. All right, that's kind of neat. I might make him jump. That'd make it more interesting. But first, we want to make it so that we can. So notice here how he thinks we're a wall. But that's okay. If he hits us in the actual game, we're gonna lose or take damage. See, we want we want to make it so that if we land on his head like this, run, Dobby, run. Okay. We want to make it so that if we land on his head, we kill him, right? So this is where we're going to go into the concept of collision layers. So you're going to see here, if you look here, 2D level 1. If you look into, we'll go into our player first. Look into our player, you're going to see in our collision object, we've got these layers here. Now, pretty much every engine has this concept of collision layers. The reason why is I know some of you have done CS with 330, the final assignment, I believe. I haven't taken that class yet, but I believe the final assignment is that you need to add collision to your circles, right? And the common question was, it seems bad to be doing O(n squared of checking every circle against every other circle in these double nested loops, right? So the way in general you get around that is one, if you look at our level here, we have static bodies. Static bodies generally don't check collision themselves. Other things check for collision against static bodies. So that's one layer of collision that gets removed. Another layer is another way that we reduce the number of physics calls is by using these collision layers. So our player, so if let's just say, first let's define our layers. So let's go into project settings, project settings. I think it's inside here, physics. Where's our physics layers? Layers. Maybe it's not inside here. Maybe it's in a different editor. Editor settings, no. I could swear it was inside here. Physics, 2D. Common. Okay, let me Google it. Scroll down to layer names. Layer names. Okay, here it is. Okay, so you can name your your physics layers. So usually you'll have something like world. World will be all of usually a lot of static objects, but anything that is part of the world and not like an enemy. You'll also have a layer called enemy, and usually you'll have a layer called player, right? So what we're going to do here, we got these 3 layers here, and if you hover over these, you'll see that it doesn't refresh it, but if we hit this refresh button, reverts it. Either way, when we restart the editor, these are going to, oh, there we go. Now it has the proper names, world, enemy, thing. So if we go to our level 1, these are static collisions here. Let's go into scene. Our static bodies, we'll select all 3. Actually don't need to be, so these are on the world layer, but they're not checking collision on anything. They're just static, right? So this should be fine. Our player here is on the player layer, so we put it on the player layer, and we also we are checking against the world and the enemy layer. So I remember, I don't remember who it was, but somebody had said that they were checking collision against themselves, which was causing false collision detection inside their project. So this is how you would get around that in a normal engine. Yourself is on a layer, and then your mask, which is what you're checking against, is on a different layer. So you're not checking collisions against yourself. And then if we go to our zombie himself is, if you go on to collision, he is on the enemy layer, and he's checking the world layer, but he's not going to check the player or the enemy layer. So if we do that, now he should just ignore me completely, or he doesn't, because I'm looking at him. Maybe. Let me see if I can. If I take the enemy off of this one, is that? Yeah, see, okay, so now notice how, since we're not checking against each other, he's just going right through me now. But that's no good, because see, now I can't attack him. So we will put on the player, keep on checking that. And that will make it so that we can do a couple of neat things. So on our player, we are going to add a little box at the bottom. We are going to add an area 2D, and this is going to have a collision shape on it. And this collision shape will be a rectangle. Now this rectangle is going to be right down here. It's going to be a little bit smaller width-wise than our It's going to be a little bit smaller than our, sorry, gonna stretch for a second here. Yeah, so it's a little bit smaller than our collision box for the main player. It goes a little bit further down into whatever is on top of, and we're gonna call this the stomping box. So whatever enters this stomping box here is going to get killed, right? And that's the plan. And it should be a little bit big. Now, if we look at our zombie, we want to define an area where it can be stomped. So we're going to do a very similar thing. We're going to put an area inside here, area 2D. We are going to put a collision shape inside. We are going to make that a rectangle. Do we want to do it this way? No, area 2Ds can't detect each other. So no, this should be fine. And we'll just do this. And it will do this and make it small enough so that it basically you have to land on it. And then what we will do, stomping box, if you look, so the way area 2Ds work versus regular collision shapes is that it is waiting for, it is checking to see if anything enters its area and then it triggers an event. In Godot, you can check events by using these signals, and you see that area entered, area exited, area shape entered, that kind of stuff. So we're going to say area shape entered, body shape entered. So we're going to do body shape entered. Is it a body? Kinematic body. I think a kinematic body is a body. So we're going to do body shape entered. We're going to put the function on our player script and we'll connect it. And now we will say, since there's only a zombie in the box, what we will say is we're going to just print the body.name, print just to see body.name. That should work. Now if we do this, we just need to land on him. Boom. Now you see that I landed on. Okay, so see, it's not only, it's also printing myself too, which is weird. That's super weird, but either way, we need to say stomping box. Is there a collision? Here. So this is going to be on it's not going to be on any layer actually, but it's going to mask against the enemy layer only. So let's see what that gives me. So it doesn't give me that, but see now it only triggers when I land on the zombie. See? And that's exactly what we want. So now all we need to do, I think I can do, so we got the body. What do we can do? Q free. Too many arguments for Q free. Okay. Body dot Q free. Can I do that? Come on. Boom. And now we can kill him. Nice. All right, so we can now kill zombies. Now that zombie's gone, and he's never come back. So let's make this interesting. Let's spawn a bunch of zombies. So we've got our level. For now, let's not spawn a bunch of zombies. Let's spawn one zombie procedurally, so that we can set up a win condition. Just so we can show how that works in general. Let me drink some more of this. I've been talking for a while now. Okay, so we want to create a list of zombies. So we will say var zombie list equal this. And it'll just be an array of zombies. Now we want to, how do I do it? Preload. Export get scene. Export scene. I think that's it. node path. No. Pack scene, that's what we want. So we want export pack scene our zombie prefab. Now if you look here on the one we have zombie prefab, what we want to do is take the zombie.tscn, drag that in. Now we have a zombie and we can delete this zombie from the scene itself. Now what we're going to do is we are going to create a zombie. We're just going to add a generic node 2D. All it has is a transform. We are going to put it here, let's say. Yeah, we'll put it up here. And then what we're going to do is every whatever seconds we are going to spawn a zombie. So what we're going to do is we're going to do var time since last zombie, and this is going to be a float, equals 0.0. If, and then we'll do it in process, our process function, we will do time since last zombie plus equal delta, and then we'll say if time since last zombie bigger than, let's say, 5 seconds. Let's say, yeah, 5 seconds is probably pretty good. Then instantiate. Let's Google that as well. Create instantiate packed scene Godot. Dot instance, is that it? So it'd be zombie prefab add child var scene pack scene dot new scene pack node no child and what we'll actually do here, we'll just call this zombies here, and then we will make we'll say zombies dot add child, so we're gonna add it there and we don't need to keep an explicit list. I think that might work. Let's see. After 5 seconds, we should get a zombie pop out of nowhere, hopefully. No? Print spawning zombie. Three, 4, 5, spawning zombie. Didn't spawn it, but the logic is sound at least. So let's try to get the zombie spawning. What am I doing wrong? I could swear that's how. Is that how I do it? 2, 3, 4, 5. No, okay. Why is this not working? It's got the zombie prefab. Instancing. Yeah, instancing. Yeah, whatever. Yeah, cool. GG script. Get node. Creating node. You can store newly created Sprite 2D.new. No. Q3. Load. Oh. I think I need to do is that what I need to do? You know what, let's just make this 1 second so we don't need to wait as long. Nope. Cannot convert from object to string. Maybe I need to separate this. Var new zombie. Why is this not spawning my zombie? What happens if I just do add child? Okay. Oh. Alright, so it's alright, I know what I did wrong. Just by looking at that. So remember how I told you earlier that you should make sure that your things are zeroed out, right? Your transforms. If you look here, my zombie prefab is all the way offset here. So if I go here and I take the transform and zero it out, and then I want to do the same thing with the player actually. Oh, with the player itself, I want to do the same thing. All right. Now, if we look at level 1, we've probably just ruined the placement of our player, which is fine. We can move him back. But now, so what was happening before is our zombie spawner is up here, but the zombies were placed so that they were actually over here in the scene. So when it got instantiated, it was getting spawned all the way over here and falling off the screen. So this should work. Okay, I get it. Stop it, zombies. All right. All right, cool. All right. So what we were going to do, we'll put this, we'll say var level, we'll say time until next zombie equal 10 seconds. What? Oh. And we'll do this, and we'll say time until next zombie, var level equal 10. We'll just say minus equal this, and we'll say time until next zombie base equal clamp float value is time until next zombie base, and we'll say 1.5 seconds, and this doesn't matter. And then time until next zombie is equal to time until next zombie base. So the reason why I did zombies.addChild is that the zombies are coming from the spawner, and I'm adding them as children to the spawner itself. That way, if I ever need to get a list of just the zombies, I can actually just do like zombies dot get children or get child count, and I can do like a if it equals 0 or something like that, then you win the game is the idea. Minus equal 0.5. So now we should get a zombie. I want a zombie right away, so let's make a function called func spawn zombie. this here. And we were going to call spawn zombie here. And when we are ready, we're going to spawn a zombie right at the beginning. And that means that this should be 10.5. So now we will get a zombie right at the beginning. And then 10 seconds later, we're going to get another zombie. And then it's going to see, and they're not colliding with each other, so so it's going to keep on spawning a zombie with a shorter time interval until it reaches every 1.5 seconds, and then it's going to spawn a zombie every 1.5 seconds. And that's what the clamp was for. Yeah, so we've got that. Now let's say we want to, yeah, so let's actually get rid of our main menu. We'll leave it there, but we won't use it this thing. But let's make a score. Let's say we want to have a score. So we can add a text field, text label. Oh no, we want a canvas, I believe. What's the name of it? Canvas. We want a canvas layer. So the canvas layer will hold all of our UI. And on this so the canvas layer spreads, takes up the entire size of your screen, basically. And then on here we will add a label. And we'll say score. And we will put another label, and we'll put this next to here, lined up with the other one. And this is going to be score label. Now we will, inside our level 1, what we can do is, remember, we can get a reference to any of our children this way. So we're going to get a reference to our score label, var score label equal UI / score label. And we want to keep track of the score. Var score equal 0. And we'll make a function called scored point. Actually, we'll make this -1 just so we can simplify some logic. And we say score plus equal 1. And then we do score label dot text, I believe, equal score. And then we can call that from our main function. And now we should have a score of 0 in the top left corner, unless we get this. And is that how you do it? I forget. No? Okay, how do I do it? Is it string? Or like that? I think it might be like that. All right, so now we have a score of 0. Okay, so to register score. So we are going to notice how this is where we, inside our player object, is where we are detecting whether or not we killed a zombie. So it makes sense here that here we would want to call a scored point, right? So usually you would think, okay, you're just going to make a method here and you're going to set a thing, but our score isn't on the player, it's actually on the level, it's on the game, right? So how do you get the value from here into your level? That's where in Godot, and there's other things inside other engines, I'm just talking about Godot here. In Godot you would use a thing called a signal. And here we could say score point, right? And you can think of this kind of like, I don't know what a good analogy to use here. But basically it's kind of like you're setting up a message queue, kind of, where you're emitting a message and you're receiving it. If you've used AngularJS used to use this. It used to have a emit and broadcast functions. it's similar to how those work. But here you would do emit scored point, I think. Emit signal. Is that it? Right, that's how you do it. Scored point. So you would emit this signal. Right? So there's a few ways. So once you have that set up, so every time you score a point, the player is going to just send a signal out into the wild, and he's just going to be like, I scored a point. The people who are interested on whether or not the player scored a point will listen for that event. So in our case, it's level 1. There's a couple of ways you can do it. The first way you can do it is you can go into your 2D scene. You can click level 1 where your script is, or where your player is here. You can hit node, and you'll see here that in our signals we've got scored point. You can double click it, and you can create a function that listens to it within your script using the UI. I don't like using the UI personally for this specific type of thing, like my own defined stuff, because if I change something, it's going to break the UI a little bit, and it's not. What I'm going to do is I'm going to register for that event, or listen to it within the function here. So what we're going to do is we're going to do it would be, so we have player object dot connect. You're connecting a signal, connecting the scored point. You're connecting to yourself. So you can connect signals to itself. So if I want to say that the zombie is interested in listening to the player signals, I can put the zombie object here and a function on the zombie object in here. And here we are going to say we are connecting to the method called scored point. So we already have that method. So what we're saying is that we're listening, this first one, we're listening for the scored point signal, which is this one here that we defined, emit signal scored point, and we defined it up here. Then inside here, we are connecting that to ourselves, to level 1, to the scored point function, which is here. And that will add a point. Now, that should be everything we need to be able to score a point. Now you see that the 1 showed up at the top corner there. And now we'll wait for another one, and this will go on forever. See, and look how easy that is. And now we're killing these guys, and I've apparently got my mechanics. I know my mechanics pretty well. There we go. Okay, so that is the scored point, how we would do that. Now let's say we want to do something similar but slightly different. We want to lose, right? We want to lose the game. Let's say if a zombie hits us, then we lose. So what we want to do is on our player here, it's going to be very similar. We are going to go to our collision here, and so we're going to do here 2D. So we want to say if a zombie hits us, then we die, right? And this might be tricky because we're using the stomping box. It might we might run into some issues, but we'll try doing that quickly. So what we're going to do is we need to do we're going to connect another signal on our collision here, collision object 2D here, mouse centered collision shape, draw, no. How did we do this? This is body entered. Collision shape, player, no. How can we do this? So, okay, so simple enough, I think. I think if we make another area, it might not be the right way, but this is how we're going to do it for now. Make another area here. No. We'll do it on the zombie, actually. We'll do it on the zombie. And we're going to add an area here. We're going to call it the player detector. And this is only going to look for the player. So on our collision layer, it's on no layers, so it's not going to collide with anybody, but it will look for the player. And then we will go to shape, shape. Why can't I see? I want a shape. Oh, I should put collision shape 2D, and we give it a rectangle. And then this one, can we make this a different color? I think we can make this a different color. Whatever. We're gonna make it a little bit wider. Oh, no, we're gonna make it the same. Yeah, a little bit wider than our actual collision. Just a tiny bit. Doesn't need to be. We'll do the bottom too, I guess. 1 second, I'll be right back. Alright, I'm back. Sorry about that. What were we doing? We were adding a collision box to the zombie to kill the player. So let's kill the player. So what we need to do, oops, whoa, jerk. Alright, let's make this bigger again. Let's move this back over. Alright, that's probably good enough. Yeah, because this is going to be a stomping area up here. Okay. So, what we want to do is connect this area, and we will do a body shape entered as well onto here. And it's going to be the same thing. We're going to first just print the name of the thing it detects, body.name. And if that works, then we'll see player. Yeah, see, and now you'll see every time hits there, it hits the player, and when it goes there, does it print it again when I land on it? No, it doesn't. Good. So we are going to make another signal, same thing, and it's going to be signal kill player, and we will just say we're going to emit the signal kill player. And in the same way that we did the player signal, we will do the zombie. So what we want to, okay, so here we have a reference to the player object directly. Now here you're going to see that we create a zombie. So here we're gonna, when we create the zombie, we're gonna need to create our connect function here. Player killed, self player killed. And this should be like this. And we will make another function here called player killed, and we'll say print player is dead. And now this should work now. It did not get it. Why did that not work? Player killed. It's because it's killed player, not player killed. Yeah, now it worked. So player's dead, player's dead. And then more, and then each one of these will work. But now see, if I'm going to try here, and now you'll see that oof. Come on. This is so hard. Anyways, we are juggling zombies now. So we killed the player. So now what we want to do is we want to pause the game. So pause mode. How do we pause the game? I think it's get tree paused equal true. And now, when we do that, if we get hit by a zombie, once it spawns another zombie on us, player's dead and everything stops. So what we will do for that is, so we pause the game and we want to show score, and allow restart. Right? So if we go back into our screen, let's design a screen. So we're going to do a couple things. For here, we're going to add another canvas item, control. We're going to add another control item here. And we're going to add this label and here, and we're going to say play, playing UI. And we need to change here UI playing UI / score label. And that should work. And then we will say, we will add a new here. We're going to say panel. And this is, we're going to lay out in the, first let's change the size of it. How do I change the size of it? Rect. We'll make this 512 by 256. And we will put this in the center. Then on this panel, we will say losing UI, lost UI. And we will add a label. You lost art. We will make this and we'll put this center top. And we will move this down a little bit. We will duplicate it. We will move it down. Your score was also make this center. Your score was, and then we duplicate this, make it down, center, align center, 25. There we go. Your score was 25, and that will fix itself. And then we will put a button on here, button. And this will be center bottom. And we'll put restart and relay out center bottom. There we go. So this is generally it. We'll move these down a little bit. Here we'll put score label and restart button. Now for the restart button, we're going to do the same type of thing. When you click restart, it emits a signal. Here, signal, we will say pressed. On restart button pressed here, and we'll just say start game. All right, and now we're going to actually create one more. We're going to duplicate this, and we're going to say start UI. And we're going to just change some of these labels. Kill the zombies. And we'll just remove these. We'll call this the start button. And kill the zombies. We will center this. Center. There we go. And the restart button, we're going to actually just call the start button. But it goes to the same here. So, what do we do for this? First thing is script. On here, start game. We need a function to start game. Function start game. I think I missed something. Let's see. Stomping box. That's not what I want. Here, start button. Signals on restart button pressed. Okay, yeah, that's fine. Goes to the same thing. It's going to start the game. The start game button is going to do. Where's my ready? It's going to do this. It's going to say this. It's going to do this. This. It's going to say, and then it's going to spawn a zombie. It's going to score a point, and it's going to say get tree dot is paused equal false. So what pause is doing is it's pausing the entire game, basically. It's stopping that update loop and that physics loop. It's stopping all of those. Well, kind of, because what we're also going to do, hello Raspberry Pi. Because what we're going to do is make it so that everything is paused until you press play, and then yeah, and then it will go. This is fine. This is fine. This is fine. What we want to do is we also want to do zombies dot get children. I think I can do for child in child.queue3. I think I can do that. And that will kill all the zombies. Player killed, player is dead. And this here we are going to show the lost UI screen. So we're going to say on ready var lost UI equal UI slash lost UI. UI dot show play UI dot hide. Do that, and then play UI start UI. There we go. This will do that. And here we on start game we will do start UI dot hide lost UI dot hide play UI dot show. Playing UI. Yeah, I'm going to continue the C++ series. This is, I injured myself a few months ago, and I've been crazy busy since then, so this is kind of just me finding a little bit of time. What is, okay. What's it yelling at? Errors. Okay, let's see. So the restart button's not working. Oh, because I need to here inspector pause mode process. So the UI is going to keep on working when, there we go. Boom. Now I just need to reset the player position. So on ready, here var player start position is equal to, oops, on ready var player start position equal player object dot get position global position. And then we do here player object dot set position set global set position global equal player. All right, that should do it, and we should have a full game loop. And then I'm going to be ending the stream. I think we're all right. Let's see. Go here, score 25. Yeah, there we go. Look at that. Now let's see if we can get 1. All right, bring it. Come got you. I got you. All right, and we'll kill one more, and then we'll get killed. And we'll see. It should give me the score. Score was 25. Oops. I forgot score label. Score label lost. It is here. There we go. That should do it. Okay, that should be it. And then boom, and we're done. And we have a full game loop. Now what we want to do is on start, we are going to ready. Here we've got this. We can do these two. We can do start UI.show get tree.pause equal true. Now we should have a start screen. Kill the zombies, and we kill it, and we've got our super casual platformer game with no real animations, but with some very basic AI, some very basic mechanics, and that's a full game right there. We also need to change the player velocity. So we will call player object.reset. Do this. We'll make this a capital R, and here we will make a function called reset. And here we will make velocity equal vector2 0 0. Can jump equal false. And then we do this. There we go. All right, so this works out pretty well. So that's pretty much like the most introductory way I know how to introduce people to game development, just kind of going through and building something fairly simple. Does anybody have any questions or something you'd like me to clarify before I sign off for the day? It's been quite a bit of time, so I think it's about time to be ending this. What's this one do? Oh, cool. Yeah, this works. This is my chat box too, right? Yeah. One thing I'll show you quickly in Godot before I sign off, while you guys think of any questions, is how to export this. So if you go into, if you want to export it to a platform, you can add your platform. You go project, and then you do project and then export. And then you'll click the add button and you'll pick the platform you want. So in this case, let's say I want to do it on Windows. You're gonna get no export templates here. You're gonna want to hit this manage export template, includes best available mirror, download and install, and then it'll download it, and then you can export it. It'll give you your exe file, your damage file, or your HTML file, or your iOS file, or your APK or AAB, or whatever file you need. This download might take a while. But that is pretty much, let me turn this off. This is blinding. That's better. Oh, but that's pretty much how you would do it. Here, actually, I forgot that I had this going on. But No problem, guys. I'm glad you guys stuck around for the whole thing, and that you guys are actually not just completely AFK. But yeah, no problem. I've been meaning to do something on this channel for a while, and this was an excuse to warm myself up again. But yeah, I'll be relatively available throughout the jam. So if you have any questions or want clarification or you're stuck on anything, yeah, I know you're looking at our face. I'm not really doing anything but downloading a template here. Yeah, I'll be around. I definitely gotta end it now. I'm falling asleep. I'm getting tired. This was 3 hours basically. So thanks for hanging around, and see you next time. If you want anything else, want me to go through any other tutorial type stuff, let me know. I'll schedule that in, and yeah, it'll be fun. And if you're not part of it already, there's a Discord down below for my own Discord and the CS Discord, all that kind of junk. Peace.